All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing some more data science stuff. We're going to be doing mostly clustering. Yeah, yeah. I mean, so yeah, it's still data science technically. Yeah. I mean, yeah. You know what? It is. Yeah, it is. I don't know why I got confused there for a second. Anyways, yeah, we are going to be looking into clustering. In yesterday's stream, yesterday I did a mute stream where I spent some time exploring linear regression more, and then I moved on to looking into clustering. And more specifically, I looked into k-means clustering. There are a couple of different clustering algorithms, and I'm going to be exploring a bunch of them. I don't know if I'm going to be exploring all of them that are available with scikit-learn, because there are a couple of them, and me going through all of them, it might not necessarily be the best use of my time. Oh yeah, okay. So I have something. I guess I should say important to show you. It's something that's different from my usual thing. Give me a second. Yeah, it's something different that I have from my usual stream setup. So previously, what I was doing was I had a project, I had a Python project set up in VS Code, and I had Jupyter Notebook installed in that, along with a bunch of other packages like Matplotlib, Seaborn, NumPy, Pandas, a bunch of like all of the data science related stuff, minus PyTorch. And what I would do is I would run. So basically with the Jupyter notebooks, the idea is that you can create notebooks, and the notebooks have cells. They can be code cells or markdown cells. Markdown cells are basically text and other stuff that markdown allows you to have. It's not just text, but like that's the basic idea. The whole idea is that you're not running code in there. And what I would be doing is, in terms of data visualization, I would type out my visualization code, and then I would see the output right below that cell. But the issue that I was having was that I would have to scroll. So imagine if I have, let's say this entire screen section is my code cell, and I run the cell, meaning I run the code. I would have to scroll down to see the output. And that's fine if I have to do it like once or twice, but when I'm constantly iterating, then having to scroll down each time just to be able to see the output, more specifically, having to scroll down to be able to see the image that is produced by Matplotlib, that was becoming a bit tedious. So I was trying to think of other ways that I can accomplish this, other workflows that I could use. And fortunately, I have a couple of machines on my network. I have a couple of systems that are available to me. So I got the idea to set up a Streamlit server and launch the Streamlit server on this machine, but then open up the web page that the Streamlit server is hosting on another machine, and that web page would have the visualization. So in this case, just as an example, this is our visualization code. It's a simple plot. It's a simple line graph, and you guys can see the line graph uh, somewhere in the center of the screen. Not exactly the center of the screen, but it should be. I'm not sure how to move my mouse. Oh, so the mouse is relative to this VS Code window. So for you guys, it should be somewhere in this region. You should be seeing it in this region. Yeah, yeah, there it is. Is Did I do that right? I think I did that right. I'm not sure if I did that right. Well, you get the point. It's somewhere in the center of the screen. What I've done is I've opened up that web page that's being hosted by Streamlit. Right now, there is a Streamlit server running, and what I've done is I've opened up the web page on two machines. One is this machine, so that I can capture it and crop it so you guys can see it. And another is like the other machine. I opened it up on another machine as well, so that I can see it on a bigger screen. And this is honestly a lot more convenient, at least for my setup. I feel like this is a lot more convenient. I don't know if I'm gonna hit any performance issues with this, or if I'm gonna hit any other kinds of issues with trying to do data science stuff in this way. I don't think I'm going to, because Streamlit it's used a lot for data science and ML related things. Like people set up entire 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 like models using Streamlit and Gradio and other such tools. So they shouldn't necessarily interfere. And in this specific instance, I'm literally just plotting one thing. Though there is a big plus side here, because I'm doing it in this way, I have a lot more real estate. I basically have a whole other screen on which I'm able to see the the plot. So what you guys are seeing in the center of the screen, I'm seeing it on like another screen, um, in like a bigger form. So that's it works out well for me, and I'm excited to test test out this method. Um, okay, so I had to set this up into columns just to, it was a sort of layout related thing. The thing with Streamlit is when you're setting up UI in Streamlit, you are kind of limited to what the UI allows, or how do I say this, in terms of layout. You're kind of limited to what, how do I explain this? There's a certain way that the layout works. You have to be within those confines, basically. That being said, it's not like it's limiting in a bad way. It still allows you to do quite a bit. And if you do want to do customizations, I believe they also allow like a custom CSS thing, but that is if you really want to go into, you know, deeply customizing the entire look. But if you don't give a shit about aesthetics, if you're just trying to make a working UI, which is usually the case with, data science and ML related stuff, they're just trying to get a working UI. If that's the case, then you can do quite a bit with the tools that Streamlit allows, or with the tools that Streamlit has, keeping in mind that you are still limited, or keeping in mind that you have to operate within the confines of of this system. They have their layout set up in a specific way, and things work in a certain way, and you have to kind of understand how those things work. So, for example, in this case, for the sake of controlling the size of this figure, I had to set up three columns. What that does is it sets up three invisible columns, and you can control the size of those columns. And then within each of those columns, you can put items, right? So if you control the size of the columns, let's say I have three columns here, and if I control the size of, if I shrink, because I'm controlling the size of all three columns, if I shrink the left and right column, that gives a lot more space for the center column, right? So that I basically use that to my advantage, and that's how I made this bigger. I can make it smaller as well. For example, I could change this to 4 and change this to 3. And no, would it be 3? I could change this to 2, and this would also be 4. So then the left and right columns are much bigger, actually double the size of the center column. And the effect of that, give me a second. I don't know if I've done the auto run thing here. Have I done the auto run thing here? Um, give it a second. Give it a second. I had to do okay, so yeah, one of the reasons I wanted to use Streamlit was because Streamlit has this option of allowing you to rerun, or you allowing the web page to rerun automatically anytime there's a change in the code. So if you just there's an option that pops up in the top right. I don't know if that was visible just now because I've cropped out this web page just so that it's showing mostly the graph. But in the top right, an option comes always rerun, and if you click that, then anytime there's a change in the code, it'll automatically rerun the whole thing. Give this a second. Okay, there it is. Right, so that is our change. And the change also reflects in the other screen that I'm looking at. So this is great. This is convenient for me because I don't have to scroll down. I can just make the change, and the change shows up in my other screen, and it also shows up in that other window, which I'm capturing so that you guys can see it. So this is great. Let me change this line graph's points a little bit. So this is X, right? We can leave this as it is. We can change Y to, actually, let's make it 4 points. Okay, and then we can change Y to be 3 and 2, and yeah, you know what? That works. That'll give like a bit of a step kind of change. Yeah, there you go. Okay, so I've got this set up now. Let's see how well this workflow works for data science related things. I'm hoping it works out well for me. Actually, this is, if I'm being honest, this is fairly convenient. Aside from the slight inconvenience of having to work within the confines of Streamlit, having to, wrap the code into these kinds of segments. Aside from that, it works out pretty well. Though, okay, what I could do is I could define a function here so that I'm not doing everything within this, width block. I can define a function here that says, I don't know, for now, let's just say draw. And in here, we can set this up. And here we call draw. Oh, draw should be, I think it has to be defined up here. Right. So if that is the case, yeah, that's gonna change. Okay, so here's what I can do. I can separate this into rendering code, or what should I call this? I should call this, yeah, this is, no, oh, page rendering. Yeah, let's call it that. So it's separated in that way. And I basically don't have to touch any of this ever, because all of this stuff that I'd set up, I don't need to change any of this. Those the left and right columns are supposed to be empty. I could make them, I could stretch it a little more by saying, okay, what would that look like? So let's say we do 2.75 and then 2.75. So 7575 would be 1.5, right? So if we do 2.75 and 2.75, we get 4 point, is it 4 or 5? I think it's 5. Yeah, it's 5.5 if we do 2 point, yeah. So we get 5.5, meaning the center gets to be 4.5 instead of 4. So we do 0.275. No. Why was I doing 2? Hold on. No, why was I doing 2? I wasn't supposed to do that. Okay, so if we do like let's do this calculation again. It's not supposed to be 0.75. It's supposed to be 275. So if I do 275, and we do 275, 275, that gives us what, 550? Right. Okay. So it's, yeah, it's technically the same calculation. Um, so 275, 275. If I've done this right, this should equal to 1, meaning we can do this. Actually, wasn't there a thing where we could specify percentages as well? There was a thing like that as well. Or maybe this is the way that you can specify percentages. I don't remember. There was a thing. Hold on. Um oh, easy. Easy. The thing froze for a second. Okay. All right. Right. What are we doing here? Okay, so these specify the percentages. The decimals specify the percentages. Or 1, 2, 3 creates 3 columns where the second one is 2 times the width of the first one, and the third one is 3 times of that width. Okay. All right, hold on. Let's test this out. Um, so it seems like that method would use like it would use like, I want to say ratios, but like technically even there it's using percentages, right? No, no. I think okay, it uses ratio. Yeah, it uses ratios there. So let's say 1 to 1. All right, cool. If I say 3, right, that's bigger. What if I do 1.75? That is actually perfect. Though I don't know if it looks that great for you guys because the crop is a little, yeah, the crop might be a little bit, yeah, I'm not too sure about this one. I mean, okay, it works. Whatever. It's not that bad. It's not that bad. All right, great. So now that we have this, now that we have this, dude, okay, it just occurred to me. I don't need. So I mean, okay, if I'm trying to, yeah, yeah, no, if I'm trying to separate the page rendering logic from um, the data science logic, then yeah, I'm probably gonna have to keep it within this. Otherwise, what I was thinking of doing was I was thinking of getting rid of this function thing and then just doing this, right? Because for some reason the indentation is kind of bugging me. Um, but I can deal with it. It's a silly thing. Um, if I did decide to do this, then it would be I would need to move this logic into this. But the problem is, anytime I need to change what is being rendered, or anytime I need to add a new. Oh, you know what I could do? Wait, I could just do this. I think that, yeah, that would work because, yeah, yeah, you know what? That would work, wouldn't it? That works. Yeah, great. Awesome. So now we don't need to have that indentation there. Um, Now, here's what we can do. I'm going to load a couple of things. So from scikit-learn, hopefully IntelliSense should be faster now as well. Um, I don't know. Let's see. What was it from? scikit-learn datasets? Or I think it was from scikit-learn import datasets. What is it? From scikit-learn. I think it's dot datasets. I don't remember. Hold on. Let's wait for IntelliSense datasets. Okay. So I'm trying to do from scikit-learn import datasets. There you go. Here I'm trying to load the iris dataset, which is we would do datasets dot load iris data. I'm mainly concerned with the data itself. Do I also need to transpose it? I think I needed to transpose it as well, didn't I? Because there was an issue with. Hold on. What if I pass a series to. Yeah. What if I pass a series to the scatter function? So that way I don't need to. Yeah, okay, hold up. So in here, if we say as frame true, that gives us a data frame. Let's do st.write. This is another thing I'm going to need to keep in mind. I can't just do print. It's going to have to be st.write. On the bright side, the code might look a little cleaner. Oh wait, yeah, I don't know if it's going to wrap the. I don't know if it's going to wrap the thing. Not wrap, but truncate it. Yeah, it might try to print the entire like 150, like the entire data frame basically. Let's see what that looks like. I don't know what that's going to look like. Let's see. Give it a second. It's doing its thing. So the way that I've cropped this web page, you guys are only seeing a specific portion of it. It is not meant to be scrolled. So if it does scroll, then you're going to be seeing a cut off portion of it. You're still only going to be seeing the cropped portion that I've set up for you to be able to see. So I need to make sure that it doesn't scroll. Though in these kinds of situations, yes, it is going to scroll. Actually, I didn't take into account what am I going to do in terms of. So, okay, something that I had in mind there was, okay, there it printed out, but there's also an error here. It can only be called once per app page and must be called as the first. Oh, okay, it must be called as the first thing. Okay, that works. That works. That's fine. All right, cool. So, right. If I access this as I forgot. Hold on. Let's see what this looks like. That does not work. Great. Uh, how do I get? Oh, I can do columns. How do I access the columns as indices? I need to look that up. Hold on. Give me a second. Pandas index columns. There was a way to go about doing it. There was okay, so uh the way to select an entire column by its name is this. Whatever the column name is, you use that. So in this case, let's say sepal length cm, right? If I save that, then it's going to show. Actually, it's not showing you guys. I didn't think about that. Fuck. Wait, are you guys able to see it? Hold on. No, you're not able to see it. It is not show. Wait, the thing is not changing. Oh, because the thing is not in focus, so it doesn't change for you guys. It changed for me, but it doesn't change for you guys. Okay, either way, I'm able to access this in this way, right? Another way to go about doing this would be if I just loaded the data set, right? And then, dude, I think I'm gonna have to wrap this whole thing into a draw function. As much as I didn't want to do that, I think I'm gonna have to do that. Because if I try to print data out, then you guys can't see it because it's going to the side. Well, then I might as well have this here as well and just call draw. It's okay. I'll deal with the extra indentation. That's not that bad. There's a problem. What's the Oh, the fact that it's not a data frame. Okay. Okay, cool. Great. Awesome. So, what are we looking at here? Okay, we are looking at the first row, right? If I want to, so this is the entire data set. And fortunately, it also gives a scroll bar so I can show you guys here. There was a table thing. Actually, hold on. What was it called? Was it called table? Was it, there was, one was data frame, and I think the other was data editor. I think so. I don't remember. Does data editor take just a regular list or does it require a data frame? Editable data at data editor. Okay, no. Let's just do table. Right, let's try printing this and okay, yeah, this is much better. And does this, no, this doesn't have a scroll bar. That's an issue. What do I do here? Okay, what does data frame, data frame just takes data, right? What if I pass in iris? Is it gonna accept it? Oh, good. Okay, it accepts it. I just realized something. I am scrolling on the other screen. You guys can't see that. I also hate that I have to sometimes bring this web page into focus so you guys can see what I'm showing because it's not working out the way that I thought it would. What's a good way to do this? Okay, let's say I keep this let's say I keep this active here and then try to move to VS Code and let's see if that maintains the focus there. Okay, so this is our data, right? What I want to do is transpose this so that each of the rows would then represent the the columns. Right now we have 150 rows and each row has 4 columns. Each column represents a different bit of data about that specific sample, right? What I want to do is transpose the thing so that the rows are what the rows are basically the columns. So you're looking at the table right now. Now let's say I call transpose and save this. Now that's what our data looks like. Did that change for you guys? Let me see on stream if that changed. Give it a second, give it a second. Right, that didn't change for you guys. Okay, that sucks. Now it should change. Yep, okay. This is awful. How do I combat this? So this is not working out. This is, oh shit, I missed the ad timer. There's going to be an ad playing in, I don't know, 10, 15, 20 seconds. But yeah, okay, to show you guys what I was talking about, once I transpose the, actually I can bring it up here. So now that I've transposed this array, if I scroll, you can see the data is laid out like this now. So basically what was previously a more vertical array, now it's a more horizontal array. And it might seem weird to set the thing up in this way, but I kind of need to do this because actually, hold on. You know, something I haven't looked into is how I would go about reading an entire column of a NumPy array. All right, there's an ad playing right now, so I'm going to take a hydration break, and I'll see you guys in 30 seconds. Oh, oh, wait. I was about to start speaking before the ad finished, but okay, fortunately, the ad just finished. Okay, um, it just occurred to me to check. Okay, Streamlit page not updating if out of focus, because I'm sure other people might be having this issue as well. Not rerunning. Let's try that. So people are having other issues, not the one that I'm having specifically. Right, so I'm gonna have to Google this later on. Either way, oh yeah, the next thing I need to look into is NumPy print column. How do I access the ith column of a NumPy array? Okay, cool. To access column 0, oh, okay, yeah. It's a similar thing in pandas as well, which I guess pandas is following NumPy's convention. I think that was the case. I'd forgotten about this. So like you can do something like this, where this is the row and then comma and this is the column. So if I just do this, it should print out the row. Oh, let's do it without the transpose. Yeah, if I do this, it should print out the entire row. But then if I do this, it should print out just one. No, it didn't. Okay, there's an issue. There is an issue. Unable to convert object of type so and so float to data frame. What am I missing here? Okay, let's try this. So this seems to work because this is giving an entire, well, this is giving, how is it that it works with this, but it doesn't work with single? Because like with a single thing, I would have to do it in this way then, wouldn't I? No, I don't. Okay, my guesses are just wrong here. How am I meant to be indexing this? How am I meant to be indexing this array? Wait, it's saying the offending output is 5.1, which is uh which is the very first data. So I think the issue is that when I do this, it is trying to use 5.1 as an index. I think that's what might be causing the issue. What if I do this? Does that work? That doesn't work. Yeah, that doesn't work. That's weird. So if I do this, then this gives us a range. This gives us 10 rows. Is that updating for you guys? I don't know if that's updating. Right. Okay. Now it update. You know what I could do? Okay, hold on. Let me try something here. So I'm gonna shrink this down. I don't know if that's gonna fuck with the window capture. Let me just see if that does anything to the window capture. Oh God. No. Yep. Okay. Nope. That that killed the window capture. Let's not do that. Let's not do that. So I am gonna need a better way to show you guys um the output. Because having to do this each time, it's not going to be convenient on stream. Like having to refocus to the web page each time. Though, to be fair, I don't have to refocus. I just need to hover my mouse over the taskbar and there, as soon as just a small preview of the window comes like, as soon as a small preview of the window shows up, it refreshes on its own. I don't even need to maximize the thing, but it's going to be a tiny bit of an inconvenience. Okay, either way. So this gives us 10. Okay, let's say I want to get between this and this, right? So that's one row. If I do that and then I do this, now it lets me access this. So I'm guessing. Okay, I need to go back and read up on indexing in NumPy because I haven't done that in a while. That being said, this kind of solves my issue because I was looking for basically this. Yeah, I was looking for basically this. So if I wanna plot like a scatter plot right now, let's get rid of this. Let's do ax.scatter. We can say iris dot no iris. Let's say I'm trying to get the first 150. No, what is it? First 150? No, first 50. And I want to get column 0 of them. And then I also want to get the first 50 and get column 1, right? And let's say I want to plot this. There we go. That is our plot. All right. Uh, oh, yeah. Something else I need to look into. Oh, you know what? I could increase the size of the plot points now because previously I had to reduce them because I was looking at them up close, but now I'm looking at them much farther away. So I can increase the sizes just so they're a little more visible. Let's try 75. Yeah, yeah, that's better. Uh, let me give me a second. Yeah, yeah. Oh, yeah, I need to look into this because here it is showing the figure in dark mode. I want the figure to be shown in, no, did I say, no, here as in, when I do it in Jupyter notebooks, then it shows the entire axes and probably the entire figure itself in dark mode. But in, in Streamlit, it shows it in light mode. So I need to change that. Streamlit, pie plot, dark mode. Theming. Oh, can I just change the theme here? I think that was the case, right? I could just change the theme in settings. So we have this and this, and let's change this to dark. That doesn't seem to be changing this. I don't know if refreshing is going to help. Let's try that. Let's try changing it on the other side as well. Because I think the default is dark mode. Yeah, I think the default is dark mode. Um, what am I supposed to do here? Pie plot figure dark. Okay, so there's some flags here that I can do or that I can use. Clear figure. If false, the figure will not be cleared after being rendered. If left unspecified, we pick a default based on the value of figure. If figure is set, this defaults to false. If figure is not set, it defaults to true. This simulates Jupyter's approach to matplotlib rendering. Okay, let's try, where was it? Here. So let's set clear figure to true. Okay, I think I'm gonna need to I'm gonna need to re-enable the always rerun thing. All right, that did not change it either. Um, how do I, okay, pyplot set background to black. Okay, plt.style.use dark background. Um, you can do this to get the hex code of the background color. Okay, now that's not what I'm looking for. The topic got closed. Wait, somebody had a useful answer here. Where's that answer gone? The easiest way would be if I could pick up the theme by, oh, okay. All right, what if I try setting plt dot, what is it? Plt dot style dot use dark underscore background. Let's see if this works. Oh shit, okay, it works. Hell yeah, dude. All right, okay. That solved our problem. This doesn't even need to be part of the draw thing. This can be separate. And now we have dark mode. Great. Awesome. Okay, so next, let's try, okay, so let's render the entire thing. So this is our entire data, okay? And here we can choose the different columns. I'm rendering entire columns of data. So because of that, we get different. Hold on. Is that changing in this one as well? No, I don't think it's changing. Now it changed. Okay. Uh, right. So we can also change it to this. Right. All of this reveals different patterns for us. Okay. Give me a second here because I'm not sure to what extent I can carry on using this. Because like this works out well for me, but like if I'm trying to show the output to you guys, it's not working out. Another way that I could go about this is I could do the always on top thing with the window. Where is that? Where is that option? Oh, what is this? No, that's list all tabs. There was an option to set the thing to always be on top. How do you do that? I've done that with other windows. Okay, I'm gonna have to figure something out here. Because this doesn't seem to be rendering. Okay, hold up. Right, so let's try changing this back. Let's say 0 here and 1 here. Okay, so this updated on the other thing. I don't know if it updated on this one. Yep, it is not updating. What if I did like an auto refresh kind of thing every 5 seconds? What if I did that? That could work. Streamlit. No, hold on. Yeah, Streamlit refresh page. Force reload of web page. Okay, automatically refresh page. Yes, that's what I'm looking for. Okay, so-and-so has created a custom component called auto refresh to solve exactly this problem. Okay, this is a custom component. To use custom components in Streamlit, you need to install PyArrow. Unfortunately, PyArrow does not yet support Python 3.9. Downgrading to so-and-so is clearly a possible fix. Okay, all right. Cross-posting from the auto refresh post. But when Python 3.3.9 was released, PyArrow, which facilitates a serialization of pandas data frames, did not support it. We added this error to so-and-so. All right. Okay. Okay. Let's try some other solution. Streamlit.server so-and-so so-and-so. Here's one way to do it with JavaScript. Okay. Um, how do I set up a timer? Let's say Streamlit timer update. How to update app elements on timer. Okay. Every file has a ctime associated with it, based on which you can know which file was last added. Okay. This seems more effort than it's worth, I think. Or, I mean, this specific solution seems more effort than it's worth. How to update app elements. Okay, how to make a timer. Because what I could do is the JavaScript solution that I'm getting here, which is um, the expression is basically doing parent.window.location.reload, right? I could do that. I could call that on a timer once I figure out how to set up a timer. Okay, what is ph here? st.empty. ph.metric, countdown so and so, 4 seconds in that, time.sleep. That's not what I'm looking for. How do I get the current time? Like somebody gave one solution and that's fine, but isn't there like some isn't there something within Streamlit itself that supports this? Nah, all of these solutions, they are, because what I was assuming was, well, I mean, no, not assuming. What I was hoping for was that there would be some kind of timer running in the background, and I could just like read that timer somehow. Update automatically every certain time. Okay, let's take a look at this. For now, you can just make a Python loop and use time.sleep to sleep 1 minute before the next iteration. It would be nice to be able to set a sleep timer though, uh, like st.rerun. I already tried something like that, but it displayed a new table. Okay. Okay, so this is from 2019. st.rerun, as suggested by so-and-so, would solve this. Okay. Okay. Do we have st.rerun? Did that? Okay, that got introduced here. It's called Streamlit halts the current page script and executes no further statements. Streamlit immediately queues the script to rerun. All right. Okay. What are... Okay, hold on. Okay, okay. What's the default? The default is app. Okay, great. Um, okay. Now, how do I set up a timer for this? Wait, let me see if there's like a if there's documentation mentioning. Um, Give me a second. Let me see if there is documentation. Okay, Streamlit rerun. See, the funny thing is I don't even know if this is gonna solve what I'm trying to if it's gonna solve the problem that I'm trying to solve. Because the issue seems to be arising because the window doesn't have focus, so it's not updating. All right, let me transition back. Okay, so this is what we are looking at. Caveats for st.rerun. st.rerun is one of the tools to control the logic of your app. While it's great for prototyping, there can be adverse effects. There can be adverse side effects. Additional script. Yo, Summer, welcome to the stream, dude. How are you doing? And yes, thank you for the hydration reminder. I just noticed that I was getting a sort of cotton mouth kind of thing. Give me a second. All right. So, yes, posture check and stretch. Give me a second. Let me get up and do that. I'm thinking I'll add squats to it as well. Squats to this channel points thing. I could I don't know, I could add a thing. It's not for It's not so people can like, stack them up. It's more so that, I don't know, every half an hour or every 1 hour or something, somebody can redeem it and I can get up and do some squats and then sit back down, because sitting for too long, it just doesn't work for me. Like, that's also one of the reasons why I don't stream for that long, because first of all, my voice doesn't let me go for that long. But even if I do manage to go for that long, sitting for too long, it just doesn't work for me. It causes me issues. And other than the issues, I also just kind of get very fidgety, I guess you can say. Like, I kind of need to be moving around. Sitting in one place just doesn't work for me. And especially when I'm streaming, when I'm talking while streaming, I kind of have to make sure that I'm talking into the mic. I can't I can't like move around as freely as I still have a fair bit of freedom, but if I want my voice to be heard on stream, I need to make sure that I'm talking close to the mic. So there's a specific posture and a specific position I have to be in if I'm talking, and I'm usually talking throughout the stream. Now that's no fun. I wanted to spam it. Nah, I don't want to. I don't want to turn it into a whole workout stream, because then what's going to happen is I'm going to be panting. I'm not going to be able to talk once I come back, because I'm just going to be panting. I'm going to have to like catch my breath. As fun as it might be, at some point maybe I can find a way to make it fun. I don't want it getting spammed, because I'm just not going to do it, and people's points are gonna get wasted. At some point, I do want to introduce something like that. Dude, you know what I want? You know what I would really like? Something, okay, my current setup is not going to allow for that, but something I do want to test out at some point is, have you ever heard of a standing desk? It's, as the name suggests, it's a desk that you stand at, and because you're standing at the desk, it has to be at an elevated height, not like a regular desk where you're sitting on a chair, right? With a standing desk, you have to have an elevated height, and you get like these adjustable standing desks where there's like a motor, or maybe that could be a manual mechanism as well. But like, uh, you have a motor that kind of raises the desk and also brings it down. So you can basically have an adjustable desk in that way. If I could set up something like that, that would be kind of cool, because that would make me stand. That would give me an excuse to stand, and because I don't want to sit for too long. Also, standing, it'll be good for the back muscles as well. It'll give me ways to, like, as I'm standing and doing various things, various computer related things. I would also then be able to do random workouts and stuff like that. Because currently I have to take out separate times. Outstanding streams, dude. Okay, that was a good one. Outstanding streams. Yeah, those streams would definitely be outstanding. I've been trying to think of ways to set something like that up. Um, I don't know. I'm gonna have to see, because the streams that I do are like, a lot of them are study streams, right? Study streams and working streams and stuff. And that means that I need to have a mouse and a keyboard. I can solve the mouse problem by creating. I'm gonna be working on something that can solve the mouse problem. I don't know how well it's gonna work, but like, I'm gonna be working on it at some point. Um, what was I saying? Yeah, I need some play, basically, because I'm doing work, right? So I need to have a desk that I can keep the keyboard on and that I can type on. And of course, I need space for the mouse as well. But the way that I've set my whole thing up, if I'm going to have a standing desk here, uh, I don't know. I don't know how good or how bad of an idea it is to have a standing desk here. I would love to try it out though for a certain period of time. But like the way that I've set things up, if I send you a pic right now, you'll see how what's the word I should be using here? How little space I would have for the standing desk, because it's not like my space is really cramped, but like the area in which I've set up my computers, because I have them in like a U shape kind of thing, just for viewing, um, and I have my bed, which is basically my computer chair. Like that's what I sit on. So um, I would have to push the bed back, but even then, I don't know if I would have space for the standing desk, because there would have to be space for the desk and for me to stand behind the desk. Give me a second. Okay, so back to what I was doing. What about your poor old legs jokes? Yeah, dude, I wanna make it a habit to stand a lot more. Of course, there would be that's another thing. There would have to be a limit to it, because like eventually it's gonna start bothering my back and my legs. So I need to be able to switch from standing desk to sitting desk um quickly, or relatively quickly, I should say. But gradually over time, I want to make it a habit to mostly stand. Uh, yeah, I want to, at least as much as I can, as much as possible. Because it's definitely not going to be possible for me to, be standing for hours on end. But I'll do what I can. Okay, so in many cases where sc.run.rerun works, callbacks may be a cleaner alternative. Containers may also be helpful. A simple, a simple example in three variations. Okay, all right. Okay. Wait, using st.rerun to update an earlier header. Okay. Using a callback. So my issue is that I need. Wait, Sama, you said it can be a 10 minutes outstanding stream redeem. That is a good idea, actually. No, you know what? If it's so, okay, I wasn't even thinking about the stream. I was thinking about my usual thing, because like I spend a lot of time on the computer, even like outside of the stream. I spend a lot of time on the computer and with computers. So I was thinking about like in that situation, but like if it's just about streaming, I think for most of the stream I can stand. I wouldn't even need a redeem for, or well, okay, I can have a redeem for that. I can have a redeem for, because initially I'm gonna have to start with like smaller times, so it can be like um 15 minutes standing or 30 minutes standing or something like that, and then I can, as I become more and more comfortable with that, I can gradually increase it to make it a little more challenging, and that'll in turn make me more used to standing more, and then eventually I'm not even going to need the redeems. I'm just going to be standing most of the time. uh yeah. Honestly, if I had like a standing desk here, I think I could change my setup a little bit. If I did get a standing desk, I don't have the money for it, so it's probably not going to happen right now. But if I did get a standing desk, or if I was able to have a standing desk made, um, I think I could do something. I think I could work something out. Um, I could probably have something custom made, and yeah, I'll have to see. I don't know. I'm gonna have to see because the way that my setup is, it currently doesn't allow for that. I can remove a bunch of things. I mean, to be honest, there's some stuff that I've kept here for the sake of having a having a desk kind of thing. And so that stuff can be replaced by the actual desk. But yeah, yeah. Okay, containers to update an earlier header. Now, you know what? Okay, all of these solutions that I'm trying to find, I feel like they're going to be more trouble than or more effort than they are worth. So I don't want to do this. I think I'll just stick with this thing where I have to hover down so I can or hover the mouse down so that it refreshes the page. And yeah, that's going to be the workflow. So anytime I make a change here, I just need to hover my mouse down here and then the change shows up. Okay, great. Dude, what if I just do, okay, hold up. So what if I do something like this? Okay, what if it's infinitely running or infinitely rerunning? Okay, what does that look like on the stream? It does not look different. Right, hold up. Let's try something here. Let's change the data. Okay, let's do 1 and let's do 2. Okay, right. That is not helping at all. So just so you guys can see, just so it adds the thing there. Actually, okay, hold up. Let me see. Give me a second. Yeah, the moment, okay, look at that. The moment I moved my mouse away from the window, it just stopped updating. And now if I hover my mouse on there again, now it's going to start updating. Hold on. Yeah, there it is. And just so you guys can see, this is what the update is doing. This is what the rerun is doing. So it basically runs the page, or, well, me placing st.rerun at the end of the page, it basically, it reruns the page, it reruns the entire script, and then it goes from the top to the bottom, and then it hits the bottom, and then it reruns again. All right, whatever. It's fine. I can just do this hovering trick and it should work. So yesterday, during yesterday's stream, I looked into k-means clustering. And I was super interested in the topic of clustering, so I was excited to, read up on the different clustering algorithms. I've mainly looked into k-means clustering because I wanted to study the thing properly. And it's kind of interesting. Yesterday, before the stream ended, like towards the end, I was trying to find ways to use the ways to use how do I say this? I was trying to find ways to use. Wait, give me a second. Because yesterday I was using a different method of printing out the data. It was a horrible method. It wasn't it was making like single calls for each data point. So if there's 150 data points, it's going to make 150 calls to ax.scatter. Whereas what I'm doing right now is passing the entire array in. So like it's just one call and then it handles all of the rendering by itself. Because I feel like there's a bit of boilerplate code that gets executed each time you call the method. So calling it multiple times would be slower than, which I mean in this case to be honest it doesn't matter because um in this case it doesn't matter because hold on, give me a second. Yeah, like I was saying, in this case it doesn't matter because I'm doing like one-off renders. It's not like constantly, it's not having to constantly update. So even doing it in the most horribly slow way is not really a problem. That being said, something just occurred to me. In scatter, when you are specifying the color, it gives you the option to specify one color or specify an array of colors for each data point. Let me show you. Um, C. C is an array like or list of color or so and so, so and so, so and so. Okay, so the color can be a scalar or a sequence of n numbers to be mapped to colors using CMap and norm, or it can be a 2D array in which the rows are RGB or RGBA, or a sequence of colors of length n. N, I'm assuming, is the size of, yeah, okay, it's part of the XY shape. Okay. Or it can be a single color format string. So what I'm thinking is, because clustering, and this is something that I didn't realize yesterday while I was experimenting, while I was playing around with k-means clustering, what I didn't realize was that the way to use the data that's given to you. So you need to have, if you're doing a scatter plot, two you need two axes, right? The x and the y. What I wasn't able to understand was how I'm meant to be using the result given by k-means clustering, or by the k-means method, by the predict method rather. Or I think even fit does it. No, predict does that. So what I couldn't figure out was what I'm supposed to be doing or how I'm meant to be using the result of the predict method. It took me some time to it took some time for it to click that what I'm supposed to be doing is, so it returns indices. The indices correspond to um what do the indices correspond to? The indices correspond to the centroids. Yeah, the indices correspond to the centroids. The centroids, each centroid represents a cluster, and it creates, like, based on how many clusters you have asked it to make, it creates that many centroids. And so it then assigns indices to each of these centroids, which you can then use for various purposes. So in my case, the way that I used it is, or rather I should say, rather than various purposes, you can use it in various ways. And the way that I used it was, I created an array. I created an array of the same size as the number of clusters, and I assigned a different color to each index. And so then I would call the scatter method for each data point, because I was iterating over the entire result of, and that's actually a pretty good way to go about it. Like it's not a very well performing method, but it was a decent way to go about it. So okay, let me demonstrate it here. So what are we saying? So let's say model equals k means I need to import a bunch of things. Hold on. From scikit-learn dot cluster, I think. Yeah. Import k-means. All right. So here I need k-means, and let's also create a variable here called n clusters. This is our total number of clusters. So in this case, let's say we want to divide this data set into 3 different clusters. So we say n clusters equals 3. And here we specify what is a argument name. This argument's name is also n clusters. N clusters equals n clusters. Great. Then what? Then we fit the model with the data. So what are we trying to do here? Maybe I should create like a separate thing. Okay. So let's say x equals iris this 1, and then y equals iris this 2. Or okay, for now we can do this. Let's say x underscore data, y underscore data. All right, then I should be able to pass in, which I don't want to be passing it into this right now. Okay, yeah, model dot fit. Oh, actually, hold up. There is a problem. So to fit the model, I just remembered that. To fit the model, we need x. Y is not used, right? We just need x, but x has to be n samples, n features. That is important. X has to be n samples, n features. How do we accomplish this? I think one way to, okay, hold on. I kind of have an idea, but I don't know if that's going to work. Let's say we do st.write. Oh, let's store it into a variable and then print it out here. Okay, so let's say we do 0 to 5, right? And then we want to get this and that. Is that going to work? Is that valid? Or is that going to throw an error? Give it a second. It's doing its thing. Okay, give it a couple more seconds, I guess. For some reason, it's being super slow right now. Well, okay, the reason it's being slow is because it's running on this machine. Okay, all right, that works. That works. Great, cool. So this is technically still an ND array. Now, what if I get the shape of this? What is that going to print out? Because if I've done this right, what we should be getting is a shape of 5, 2. Yes, it gives us a shape of 5, 2. All right, great. Oh, is it supposed to be right or just text? I don't remember. Well, I guess each one of them has its pros and cons. Great. So this is what we can pass in. We can pass in wait, let's create a separate thing, x fit data. That way I can remember what I'm supposed to be passing in. Let's also do call o1, call, no, let's not do that. How do I want to, okay, let's say c1, c2 equals 0 and 1. And then here we want to pass in c1 and c2. And here we want to pass in c1 and c2, just so it's a little more dynamic. And I just have to change this. Well, I just have to change this, which is our column numbers. Column indices. Okay. All right, great. So if we do this, that's going to throw an error. I shouldn't have hit save, which is fine. That's okay. So I'm trying to pass in fit data here. So we're going to pass in x fit data. I'm glad that I figured out this indexing thing with NumPy. I feel like I need to go back and learn or refresh my knowledge on some of the basics of indexing NumPy arrays, because I know the simple indexing, which is usually row based, and then finding and then getting the columns per row, but then doing slightly more advanced stuff, I haven't like touched it in a while. Or I usually have my own alternate methods of doing it. Like earlier I was doing, like, in fact, prior to the stream, I was what I would do is I would transpose the data. I would transpose the entire like array so that the columns then become rows, and then it becomes easy to index them, right? Or I would use a pandas array. I would, no, not a pandas array, a pandas data frame. I would convert, or I would read the iris data as a data frame, and then I can just access the individual columns. But yeah, okay, cool, great. So what was I doing? Yeah, so here we fit the model. That's great. Right, once we fit the model, actually let me show you guys what the centroids look like, because it gives you the centroid positions. Once you fit the model, it gives you the cluster centers and labels as well. Where's my print statement? I don't think I have one. Okay, so let's say model dot cluster centers, and then model dot labels. Labels are, I believe, just indices. Okay, I don't remember. Let me see. Oh wait, this clustering it's gonna fail. I just realized that it's, well, not exactly fail, but it's not gonna give the best results, I should say. How many values are we looking at here? It's got to be 50. Right. So the labels mention for each of these values something that I've noticed is that, okay, you get these labels, right? If you call predict on the same data, it's going to give you exactly these labels. So the wait, you guys can't see it, can you? You can't see it. There you go. So these are the centroids. Each of these locations. So these are XY positions on the scatter plot, right? Each of these rows represents, how do I select it? So each of these rows represents one centroid position. And in this case, it's 3 clusters, so there are 3 centroids. And all of the other clustering is going to be done, or rather, I should say, the clustering algorithm is going to divide up the data into these 3 clusters. Okay. All right. So here, let's say what are we trying to do? Okay, so let's create a colors thing, and let's have 3 colors for now. I wanted to make it dynamic. I made it dynamic. Oh shit. I missed the ad break timer. There's going to be an ad playing soon. Should we just wait until the ad plays? Because that works for nah, I can keep talking. Okay. So what are we trying to do here? We are trying to do numpy.random, because I wanna assign random colors. Right now it's only 3 clusters, right? What if I wanted to, you know what? Okay. We can have two. We can have 2 declarations. One is going to be this tedious one, which is I'll create 3. Actually, no, this, okay. The ad is playing right now, so I'm going to take a hydration break. I'll see you guys in 30 seconds. All right, welcome back. So, fortunately, the scatter method accepts colors in many different formats. So it takes lists of either 0 to 1 or 0 to 255. I think it's 0 to 1. So it takes colors in that format, which can be, you know, the RGB or RGBA values, or it can also take hex encoded. So I can do, for red, I can do this, and then I can do green, then I can do blue, and okay, we can do 2 more. So let's say what red and blue would make magenta, so that's magenta, and then green and blue would make cyan. Red and green would make yellow. So that is our yellow. And then this is our cyan. Hold on. Let's do this. Green and blue. That is our cyan. So we have 6 colors here. For now, we can use this, but I also want to use this for a random thing. So we have np.random. I think choice. I think it was choice, wasn't it? What does choice do? I think choice gives it generates a random sample from a given 1D array. This is, yeah, this is supposed to be, oh yeah, okay, so if I give it just 1, then it does between 0 and 1. And the size I can specify here as no, there was a different way that I had gone about this. There was a different way that I'd gone about this. Hold on. So it was np dot. What did I do in the previous thing? Because, okay, hold up. So if I do this, if I do choice, wait, let me test this out. Let's try printing out. So np.random. choice, let's say 1, and the size we want 1 row and 3 columns. Let's run that. That gives 0. That gives 0. All right. What about np.random? Oh, wait, let's put it in there. So np.random.random. Okay, this, right. And then here we can, oh yeah, this is how I had done it. Okay, so then here I specified this, and that gives us a different value each time. Oh yeah, you guys can't see it. Let me do this. Yeah, there you go. That's a different value. Give me a second. Okay. All right. So that is one color. Okay. That is one color. So then what I could do is I could do random.random, which is going to generate a color between 0 or, well, it's going to generate a value between 0 and 1, but it's also going to generate an array of that shape for x in range and clusters. So it's going to create as many colors as the number of clusters that we have. And that'll give us random colors. So I could then increase the number of clusters to 10 as well, and it would scale the color thing. Awesome. Now, what was I trying to do? So we fit the model and then we predict, right? I don't necessarily need to predict though, because I'm doing it on the exact same data. So the prediction is unnecessary. So we can just do model, actually let's do label. So model dot labels, and this will be our centroids, model dot cluster centers. Okay, great. So now that we have that, so there's something that I wanted to look into, which is I wanted to try doing a list comprehension. Okay, there's something I want to test out before I do that. So let's say ax.scatter. Let's say 1, 2, 3. And here also we say 1, 2, 3. And then the color, let's say we want red, green, and blue. Is that going to work? Yes, that works. I don't know if the points are visible to you guys, but that works. Maybe hold on. I should change the figure size here. Because I feel like because I made the figure size so big, the points also end up being smaller. But like I kind of want the figure size big. It's just that I don't want the points to be like super small. But yeah, that works. So something that I want to try, I should be able to pull this off, to be honest. I should be able to pull this off. If I get the list comprehension right. If I get the list comprehension right. So I have the colors, right? I have our colors array set up. Okay. Here we want to pass in what? X data and then Y data, right? Okay. What's this going to do to the size? Okay, that makes it pretty decently big. All right, so that is our entire data, right? And then for the color, we can have a list. X for X in labels. Okay, so we are reading labels, right? We are reading labels. We want to pull that. Yes, yes, because labels contains the index. Okay, so in theory, this should work, but let's see if it really works. Nope, that didn't work. There is an issue. Just so you guys can see the error that popped up, I'll refresh the thing. There's an issue here. Oh, that's the issue. It's because I was supposed to be passing in the entire data set. There it is. It works. Great. Cool. Awesome. You guys can see it. Give it a second. Oh, wait. I'm on a bit of a delay here. Okay, yeah. So you guys can see it. Oh, I just realized. Oh, okay. Hold on. You guys can't see the green points because they're getting green screened out. You know what? Let's try this random colors thing. Yeah, that's better. That's actually much better. You should be able to see that. Okay. Why didn't that? Why am I on such a delay, dude? Holy shit. What? What is going on? I'm on a crazy delay. But yeah, either way, that is our k-means clustering. Now, something that I'm trying to understand is so I'm okay. First of all, I need to get a better understanding of how exactly k-means clustering is is deciding the positions because from what I've understood, it creates centroids and then it just iterates over all of the points per centroid. It iterates over all of the points in the data set, and it constantly keeps calculating the mean. And there's a threshold when hold on, hold on. I'm forgetting how the thing works. So the idea that like so what I understood so far was that it iterates over. So first of all, it chooses specific centroids, right? Specific positions for the centroids, and then it iterates over the entire data set or the entire like set of data points, and it's constantly calculating the mean between between the data point and and the centroid. And there's a threshold that is set where it kind of takes the difference between the old centroid position and the new centroid position, or the old data point and the new data point. No, I'm forgetting. Hold on, dude. There was a thing where it takes a difference. Like basically, it calculates the mean between the data point and the centroid, and if it's below a certain threshold, then then that data point belongs to that cluster, belongs to that centroid. That's what I'm trying to explain. I'm just not able to remember the I'm not able to remember the difference part. There was a thing that was being mentioned for the difference. Let me hold on. Give me a second. Okay. All right. Centroids. Okay. Okay. All right. All right. So here's the working. The first step is to choose the initial centroids. Okay. With the most basic method being to choose k samples from so and so. After initialization, K-means consists of looping between the other two steps, which I'm going to tell now. The first step assigns each sample to its nearest centroid, and the second step creates new centroids by taking the mean value of all the samples assigned to the. Oh, that's what I was forgetting. It's not individuals. Like, it's all the previous samples that have been assigned to the centroid. The difference between the old and the new centroid is computed, and the algorithm repeats itself until the value is less than a threshold. Okay, so let's try to imagine this. Let's try to imagine this. It is recalculating centroids. It is recalculating centroids. So earlier, I think the explanation that I'd given was wrong. It was definitely wrong. Yeah, because what I was thinking of was more the centroids being in the same place. But it seems here that the centroids are moving around based on like the calculation. Though how are the centroids really moving around? The second step creates new centroids by taking the mean of all the samples assigned to each. Oh, back up. The first step assigns each sample to its nearest centroid. Okay, okay. All right, now I get it. So it's already assigning it to the nearest centroid. I'm guessing it's just getting the distance, right, between the points. Then the second step creates new centroids by taking the mean value of all the samples. Okay, that makes sense. Yep. Because you've assigned all of the samples to their own individual centroids, you're going to get the mean and then create a new centroid. All right. And then the difference between the old and the new centroid is computed. Okay. And then the algorithm repeats. So it basically, actually, I think it's just the two steps that repeat, not all three. Yeah. And the algorithm repeats these last two steps until the value is less than a significant threshold. Until the value is less than a significant threshold. So let's imagine this, right? Let's say we have two centroids. Let's say we have three centroids, and we have 150 data points. Okay, let's say 50 data points got assigned to one centroid. Now we calculate the mean of these we calculate the mean of these 50 data points, and that becomes our new centroid. And then we get the difference between the old centroid position and the new centroid position. And we have a threshold. If it is, if the difference is above, so if it's bigger than the threshold that we have set, that means that it's far away from the current centroid. Meaning we have to repeat this calculation again. So we store the new centroid's position and repeat the whole. If we repeat the calculation again, won't we just get the second centroid again? How is it moving then? The difference between the old and the new centroids are computed, and the algorithm repeats these last two steps until this value is less than a significant threshold, or is less than a threshold. Yeah, no, I'm not getting it. So the this wait. So let's say the first time we had a difference, right? And we repeated the last two steps. After initialization, k-means consists of looping between the other two. The first step is to assign each sample to its... Oh, it reassigns. It reassigns. Okay, it's reassigning. It is reassigning and then recalculating, and then it's getting the difference between the two centroids again and again and again until there isn't significant movement in the centroid. Dude, I feel like I can implement this algorithm. Yeah, I feel like I can implement this algorithm, and then we would be able to see like a step by step thing. But like if I wanna if I wanna visualize this as an animation kind of thing, I would have to look into Matplotlib's animation stuff. I don't know if I want to do that. I mean, to be honest, there's a bunch of other things that I want to look into Matplotlib's animation system for. Um, yeah, I'm not sure. No, you know what? Let's look into it real quick. Give me a second. Also, the music has stopped. Let's continue that and okay. Um, Matplotlib animation. Okay, this is the API, and this is the user guide, I guess. Based on its plotting functionality, Matplotlib also provides an interface to generate animations using the animation module. An animation is a sequence of frames where each frame corresponds to... By the way, I didn't mention this because I got sucked into the like explaining and actually before that understanding, re-understanding, understanding. No, I feel like I only got a better understanding of it this time around when I read the explanation again. Because the past few times that I read it, the explanation that or the understanding that I had, it was very incomplete. And until I tried to explain it on stream, I didn't realize how incomplete my understanding of it was. Now I actually get it. Either way, given the working of k-means, I'm trying to understand the behavior of k-means clustering because I've noticed situations where the clusters severely overlap each other, and so there isn't really a whole lot of clustering going on. It just looks like noise. I can show you an example by loading. I think the wine data set is a good example. Hold on. Yeah, yeah. I should create a data thing. So let's say data equals iris. And then here I can use data. So then data can become like it can become like an abstraction variable, I guess. I don't know what else to call it. This makes it easier for me to like switch out data sets. So here I can do wine equals datasets dot load wine. Data. And then here I switch it out here. And then here I can specify the columns. So let's say I did these columns, okay? And let's say we are doing 3 clusters. did that catch it? I don't know if that caught it. Was it wine or diabetes? I don't remember. Hold on, just so you guys can also see it. Let me bring it up here. No, this is clustering properly. I was having issues with something else. Was it the number of clusters? No, or maybe it wasn't this. Let's try, I don't know, this. I'm trying to reproduce the problem. What if I did 5 clusters? No, this is clustering properly. This is clustering really well. Why was it not clustering properly before? Right, I'm curious about this. Why was it not clustering properly before? What exactly, which one was it? Was it the diabetes data set? Let's open that up, or let's load that up. Diabetes, okay, data, and then here we can do diab, and I don't remember how many it had, but nope, this is clustered really well. That is a lot of data points, but this is clustered really well for that. Dude, I was having issues. What was I have? What now? I'm curious, dude. Hold on. This might slow things down, but I'm gonna open up my other project. It's not gonna show up on stream, but I'm curious where exactly I was having problems, where exactly I was having issues. I just need to see the code that was producing that that noise. I cannot remember which specific columns and which specific data set it was. But I do remember seeing a whole bunch of noise. And that's when I did some research and found out that yes, k-means clustering does have its limitations, and there are certain situations where it doesn't perform very well. Okay, give me a second. Oh God, this is gonna kill my frames. Oh, you know what I could do? Instead of doing this and killing the frames, I could open up the code for, oh wait, yeah, no, it's a, how do I open this up? I don't have Jupyter notebooks. I don't have Jupyter notebook in this project. If I open up the Jupyter notebook in that, in Notepad, I don't know if the text is gonna, I don't know, man. I'm really curious now about which data set it was, because this is clustering incredibly well. What if I increase it to 10? Nah, dude, this is clustering super well. This is not overlapping at all. Oh, yeah, just so you guys can see the updated version. This is not overlapping at all. What exactly was overlapping then? Nope. No overlap here either. Was it because of was it because of the seed? So let's add like a random seed here. Let's see if that affects it. No, the seed is also not having adverse effects. Whew. What exactly was it? Because when I call okay, in the other project, I think I did call predict. So let's say model dot predict. It is expecting n samples and features, and I'm basically just passing in the fit data in there. And then that returns, well, that returns labels, right? Okay, so let's say res equals predict, and then here we use res instead of, yeah, that's still great. That is still great. Like, it's still working. What was the what was the situation, dude? I remember having a situation where it wasn't okay. You know what? I'm gonna do it. I'm gonna load the thing because I want to reproduce this problem. If it causes a bit of lag, that's okay. That's fine. I'll open the thing up and then I'll close it quick, I guess. I don't know. All right. So I'm opening up the data science project. All right. Give it a couple of seconds. Hopefully it's going to be quick. Actually, it's not going to be quick. It's going to take some time because it has to load the extension, it has to load the notebook, then it has to detect the environment and load the environment as well. And oh, good. Okay, okay. It loaded the notebook and now it's loading the environment, which I don't need to wait for. That's okay. Okay, so this was not in the iris data set. Oh crap, I changed it. Shit. Okay, I changed it and I don't know. Yep, okay, I don't have it. So here's what we're going to do. We're just going to experiment with a bunch of different, I don't remember which ones are what. Okay, we're just going to experiment with different column. We're just going to experiment with different column indices. That's the word I was looking for. We're going to experiment with different column indices until we eventually run into that issue. This seems like a fool's errand, but I'm doing it anyways. Because like I'm gonna run into the problem later on eventually, anyways. But like I'm trying to reproduce it right now because there was so right now we are seeing like great clustering here. This is amazing clustering, dude. This is actually great. What if I gave it a bad number of clusters? Okay, so let's say I said 2 clusters. What if I did 8 clusters? 8 seems like the optimum number. No, this is clustering it pretty well. Yeah, nope. This is clustering it pretty well. It's not like all over the place or anything. Um, I don't know, let's say this. Nah, we are still seeing pretty decent clusters. How is it that I was getting fucking noise, but right now there's barely any noise? Okay, there's something interesting to be noted about the way that these there's something interesting to be noted about the shape of these clusters. Cuz if it is, because if it's looking for dataset dataset points that are nearest to a specific centroid, okay, I lost my train of thought. I was trying to figure out that how we are arriving at these kinds of clusters. Either way, I'm trying to reproduce the problem that I was having. Let me try to. Okay, so uh, let's get the shape of this. The shape is either 10 or 19. I can't read that properly. Wait, no, I think I can fix that. Text. I think that's 10. I think that's 10. Yeah. Okay. So we have 10 rows, 10 columns, and 400 something, 400 something rows. So let's say 9 and 7. No, dude, this is great. This is actually clustering it pretty well. Oh, wait a second. I was looking at the shape of the diabetes data set. I'm supposed to be looking at the wine data set. So let's print that out. It has, I think, 13 columns. Okay, so let's say 12 here and 11 here. Yeah, I'm not sure how I'm supposed to reproduce the problem, which has me curious. Like, okay, wait, dude, how did I? Was it because of a low number of data points? Could that be it? Like, let's say I only took 20 data points in wine and I use, nope, even that clustering is great. Um, let's say I did, I don't know, 100. Even that clustering is great. How did I run into an issue? I'm super confused about how I ran into an issue. Was my logic fucked up maybe? Though I don't see how it could have been, how that could have caused an issue here because, so okay, in the other situation, what I was doing was I was iterating n, I, and for n, I in enumerate labels, and then in here I was doing the scatter thing, right? AX scatter. N is supposed to be the n is supposed to be the index of yeah, n is supposed to be the index of what we are currently, like, iterating over, and I is supposed to be the value at n in labels. That's the best way that I can put it. Okay, so what I was doing was I was iterating over x data n and y data n, and then for c I was doing this colors I. I think I need to set the scale as well. Let's set that to 75. So this is what I was doing with the previous logic. It's doing pretty much the same thing. At least I thought it was. Yeah, apparently it's doing the same thing. Like, look at that result as well. It's doing the exact same thing. Yeah, dude. I'm Oh, okay, there's something interesting to be noted. Now that I'm looking at it, now that I have a chance to comment on it, let me just mention, or now that it's still, as long as it's still in my mind before I forget it, something interesting to notice about this is, as you give it more and more clusters, the clusters start to get more squished on one given axis, and they start to become like more and more flat. So they start to look more like strips. Like, this is a good example. I tried to let's change the shape. Let's try something like this. Give it a second. Maybe this is not the best example because of the shape, but like you can kind of still see what I'm talking about. Let me change it to something that was more like dense. Wow, okay, so this method is actually incredibly slow. Versus if I did this, holy fuck, it is much faster. Okay, all right. I'm actually seeing the difference between the time. You guys can't see it because, like, when you see the thing being updated, it's being updated because I did the whole mouse hovering over the tab and stuff like that, or over the window. That's when you guys are seeing it, but like I can see the difference. Which, I mean, I was doubtful. I had a doubt that calling scatter per data point is definitely going to be introducing some kind of overhead, because there's like a bunch of other things that have to happen before and after the rendering as well. And if we are calling it that many times, I feel like it's going to be much slower than if we called it once and just passed it a whole bunch of data so that it can do its processing in its own way. Because I'm sure these methods have been written in such a way that they process entire batches of data. You're not meant to be calling them per data point. I was doing it because at the time that's what occurred to me, and that's what was simpler to do. But yeah, okay, so take a look at, and okay, let me reduce the number of clusters so you can see the strips like more fat. So take a look at these clusters, right? The clusters start to look more like strips, and they can go on either axis. It doesn't like pick a specific axis. It can either be horizontal or vertical. I haven't seen it being diagonal, but um, I've definitely seen horizontal and vertical. Um, I've also seen when it's like when you have smaller clusters and you have like you tend to have. So I was about to say you tend to have these more like spherical type shapes, but something interesting to notice here is let me refresh this. Look at this vertical line between these data points. Seems like a very straight line. Look at that. I don't know what this is saying, but these are just observations that I'm making between like within each of these clustering things. Within each of these clusters, I guess. Dude, I'm interested to find out like what exactly these things say. What exactly these shapes and these lines and stuff say. Because it has to be revealing something, right? So far, I'm just seeing the visualization of it. Like, okay, this is a vertical line, this is a horizontal line. Maybe at some point, we're going to be seeing diagonal lines as well. If we look at the clustering page, which is here, there was something interesting. I need to take a look at all of these data sets, whatever all of these data sets belong to. And I want to try visualizing each of these data sets and seeing how they get divided up into different clusters. I also want to try and implement the k-means clustering algorithm. I don't know if I'm going to implement the initialization method because there's some sort of like smart initialization method where it tries to make sure that the centroids are not close to each other. I don't think I'm going to implement that. So my thing is still going to be a bit flawed, but I want to try and implement the actual clustering algorithm because it seems kind of interesting. I want to implement it and try and visualize it as well using Matplotlib's animation thing. So this says it's comparing different clustering algorithms on toy datasets. Uh, of the toy datasets, there's a couple that I'm yet to try. Like I haven't touched the digits, the handwritten digits dataset. I haven't touched the text-based ones. There was something to do with exercise as well. I haven't touched that. I haven't touched that either. Yeah, you know what? I should try. I should try that. I should definitely try that. All right. Okay. So I think that's going to be it for today's stream. Do stick around. I'm going to be raiding someone. Okay. Um, uh, I don't feel like I don't feel like being chatty too much. So you know what? Okay, here's what we're gonna do. Um, I'm gonna raid Oz. Let's raid Little Witch Oz. Oz is cool people. Oz is a friend. She's a game developer. You guys are gonna see what else she does, but she's a game developer, a gamer, a programmer, an artist, and she does a bunch of things. Right now, she's doing some game dev stuff, I think. Um, So yeah, that's gonna be it for today's stream. Maybe I might do a sculpting stream later. I think I might actually do a sculpting stream later, maybe in like 1 or 2 hours or 3 hours or something. I'll see. Um, Summer, thanks for stopping by. Thanks for hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. I hope you guys have a nice day, and I will see you all next time. Peace.